In the past videos, we talked about some of the types of isomers we can have with a given molecule. Let's briefly review the types of isomers you should know by now. The first type of isomer we should review are constitutional isomers. Constitutional or structural isomers are defined as isomers that have different connectivity of atoms in 3D space and yet the same chemical formula. One example is straight-chain butane and all the common names for branched butane we learned in this chapter. The chemical formula is the same for all of them, C4H10, but the carbons are arranged differently. Isomers may have different boiling points, melting points, intermolecular forces, and solubilities. Our next broad group of isomers includes stereoisomers. Stereoisomers are defined as isomers that have different arrangement of atoms in 3D space, and of course the same chemical formula. The connectivity of these atoms doesn't change. In other words, the atoms may be connected the same way, but the way they look differs. Stereoisomers divide into two groups called diastereomers and enantiomers. I don't yet want to define these two terms. I want to focus on the two groups that diastereomers divide into, cis-trans isomers and conformational isomers. We already talked about a form of cis-trans isometry, in the form of double bonds. However, we can sometimes refer to the differences in 3D orientation as cis or trans. Take this cyclohexane with bromines attached to the ring via wedge. We can compare the two bromines since they are the same constituent relative to another, and say that substituents are cis. However, if one were on a dash and the other on a wedge, the bromines would be trans relative to another. The most important concept to take away from cis-trans isomers is that we need to include terminology in our IUPAC name. For instance, if I asked you to draw 1,2-dichloro-2-butene, which one of these structures would you draw? Well, you wouldn't be able to differentiate. We need to include cis or trans in front of the IUPAC name to specify which one of these isomers to draw. As you may remember, cis-trans isometry centers around carbons that are not free to rotate around one another, such as double bonds and rings. However, conformers or conformational isomers are almost the opposite. Conformational isomers focus on the ability of sigma bonds to rotate. In the next video, I'll introduce conformational isomers and a new type of structure we need to understand in order to draw conformers. Practice these concepts using the worksheets and answer keys, as well as explainer videos available for free in the description below. See you guys in the next video.